This is the Smart Buildings Academy podcast with Phil Zito, episode 338. Hey folks, Phil Zito here, and welcome to the Smart Buildings Academy podcast. In this episode, we are going to be diving into looking at cost savings related to proportional versus floating controlled actuators. But actually, we're going to dive a little bit deeper based on some conversations that I've had with customers lately around the parts shortage. And we're going to talk through some strategies of dealing with the parts shortage because that seems to be very top of mind for a lot of people. So first thing we'll dive through is this concept of good, better, best in relation to costs associated with products. And then we'll expand that out to look at all of these parts shortages that are going on right now and how do we deal with those on our projects, because that's going to become really freaking painful in just about a month. I know it's painful now, but about a month from now, when all the schoolwork starts to kick off and you're waiting 16 weeks for controllers, that's going to be a pain point. All right, so let's first talk through this proportional versus floating control. So proportional control, quite simply, is you get a 0 to 10 or a 4 to 20 output from your controller, 4 to 20 milliamp, 0 to 10 volts DC. Those are the most common. And you'll get these outputs, and these outputs will go and drive a proportional response on a actuator. Okay, so that is kind of where this proportional concept comes in. Now, floating is where you actually use two binary outputs, and these two binary outputs are going to go, and what they're going to do, and I just want to check my sound real quick. Okay, everything sounds good. I just had to do a computer reset, so I wanted to make sure sound was still sounding good, and it sounded good. All right, so floating control is you have these two binary outputs with a shared common typically, and when you drive binary output 1, it will drive the actuator clockwise, and then when you drive binary output 2, it'll drive it counterclockwise, and you have a timing on the logic block inside the controller, and that logic block will determine how long you should stroke the counterclockwise or clockwise commands to open or shut the actuator. And that in turn will go and also remember where you are at with the actuator so that it can properly control. Now, why would you use one over the other? Well, I'm not going to quote costs because I don't want to go and make this episode, something that's tied to the prices of this specific time. But suffice to say, in proportional controllers, what we typically have is we have this device inside the proportional actuator that takes that 0 to 10, 2 to 10, 0 to 5, 4 to 20 milliamp signal, whatever it is, takes that and then induces a command basically onto the actuator motor that then tells the motor what percentage to go. There's a lot of ways it's done. Most commonly, it's done by going and affecting the power, the amount of power, usually like the frequency that is able to drive the motor. And thus, it drives it to a certain percentage and then it stops driving it. And usually it'll hold it kind of in place. And sometimes it holds it in place. Sometimes you have spring return. There's a variety of different methods. Suffice to say that little device inside the actuator adds an additional anywhere from $20 to $40 of cost at the time of this recording. So we're talking usually like if an actuator is $90 for floating and a proportional actuator is $120, $130, then you're talking, anywhere from a 20 to 25% cost increase. It doesn't seem like a big deal, right? To get that benefit of that proportional control, which is more precise, and additionally is less likely to get out of calibration like floating control can tend to do. The challenge becomes, however, that if you have 1,000 of these devices, and you've got a 20%, 25% cost premium, 1,000 times, let's just use the number $20, that's $20,000 in additional material cost that you're adding to a job. And so right off the bat, you can reduce your cost, and that's cost. That's not with any markup or margin applied. So initially, right off the bat, you can reduce that cost by 20 grand on 1,000 actuators, which on large jobs is not hard to see. And oftentimes these large plan and spec jobs can come down to, who can be 1% to 2% less than their competitors in selecting them for the job. So, these cost savings can become pretty important. Now, that being said, let's talk about cost savings and products and this product shortage, because while I was just going to cover proportional versus floating control today, I feel like this product shortage is more timely. So depending on who you're working with, the product shortage is putting you into a scenario where you have anywhere from a 12, and it seems like we have a stream issue with give me 1 second here. Let me see about our baud rate. I'm going to adjust our baud rate up just a little bit. Hold on real quickly. There we go. That should fix that. Okay, cool. So like I was saying, what is going on, what you're seeing in the market right now is anywhere from a 12 to 16 week lead time on products on average, with some folks seeing lead times of almost to half a year. That's insane. So how can you deal with this? Well, if it's sensors, it's relatively easy, right? You just go and find, there's so many sensors. There's BAPI, there's ACI, there's Citra, Veris, etc., depending on who you're using. And so you can try to go and find equivalent sensors. You can ask yourself, and this is how I approach it, like our students use the CWE2 for CO2 to be able to do 4 to 20 and 0 to 10 as part of their wiring exercises. But the CWE2, depending on the model version you get, one of them you can get pretty quickly within a couple weeks. Another model takes a couple months. So being able to ask yourself, like, do I need all of these capabilities? So for example, you look at something like a CWE2, and if I pull up this spreadsheet here, which I'm not going to share, but if I pull this up and I start to look at the catalog sheet here, and I start to analyze, like, what does this catalog sheet have? Like, what capabilities does this sensor have? I can start to realize that there's a lot of capabilities. I can see that I have different sensor types of 10K, of platinum, 1K, etc. I can see I have housing types. I can see things like I have a variety of different contacts I can make, all sorts of stuff. So by going and selecting specifically a different sensor, you can go and reduce lead time. So that's my first tip to you. Whenever you're sitting there and someone tells you initially you have a high lead time, you need to look at other products in that family and ask if you would have the same lead time. Because sometimes the additional cost, and sometimes they're even less cost, but sometimes the additional cost is going to outweigh the potential for going and having that lead time delay. Now you may say to yourself, but Phil, that's additional cost I have to add to the project that I wasn't planning on adding. That's why I'm a firm believer that a lot of your scope letters that going out, I'm not a lawyer, so consult with a lawyer, but your scope letters that are going out into the market right now should have something to the effect of that we reserve the right to replace this sensor with customer approval at cost plus 10, whatever, due to the lead time shortage. And put that in there, and then just simply have a process where when you need to replace the sensor with something else that you can actually get, you can go to the contact or to the customer, and you can go and see with the customer that they give you approval on that specific sensor, right? I'll get to your question in just a second. I see that we got a question in chat, and I'll talk through that in just a second. All right, so another thing that we need to consider here in regards to our products is also we need to start to think about the controllers. And this is where things get a little squirrely, right? Because we can go and we can get our sensors. That's pretty easy. But when we start to deal with controllers, that's where things get squirrely. One tip that I've seen from several of our customers that they're doing is they are using IOM modules. Now, there's pros and cons to this. An IOM module is an input-output module. The pro of an IOM in a lot of cases is it does not necessarily have the same CPU chip that the main controllers have. And because of that, the lead time on IOMs, input-output modules, is less than the lead time on controllers. So you'd say, okay, well, I'm going to just put in a ton of IOMs and call it a day. Now, there is a con to IOMs, especially if you're using them like a lot of our customers are using them, where you have a centralized controller and then you have a remote IOM. So you may be doing a central utility plant controller, and then you've got an IOM in a enclosure sitting out with the cooling towers, and it's a remote IOM module. Now, there is the potential for damage to that communication bus. There is the potential for damage to that controller, and that could cause that IOM to no longer function. That could cause you to lose a portion of your central utility plant. Additionally, now you have two potential products that you need to stock from a continuity perspective. You have a controller product, but you also have an IOM product that you need to stock. However, that being said, if you can't get product and or you can get limited product, using the IOM might be a solution for you, because that input-output module enables you to be able to go and reduce your dependency on chip-based controllers, which are the ones that have the major delays. An additional thing I have seen several of our customers doing is that they are looking at alternatives that are still manufacturer specific. So you have Honeywell, and Honeywell has a slew of products, right? For example, they have EBI, they have Honeywell Webs, they have, you could argue any tritium product is technically a Honeywell product. So depending on how the spec language is written and who is written as a qualified product, you may be able to do alternates. So especially if it's a Niagara spec, and I'm not sitting here advocating Niagara specs, I'm just saying that they seem to have the most diverse set of controller products on the market. So for example, a lot of our students will use Cyper 10s for our courses, but they can't get a Cyper 10, so they'll use an Edge 10, or they'll use a Link Spring, I think 854. So they'll use alternative products. So that's another thing. If you are not flat spec to a specific OEM, that does potentially open you up to being able to go and source other products. So just because it says Honeywell Webs or, you know, FX or something like that does not necessarily mean that it is set in stone. That is something that you can do what's called an add alternate, where you basically submit a request to add an alternate and you explain that it uses the same framework, and then you can go and potentially get approval. Additionally, things like BACnet VFDs, things like BACnet flow sensors, BACnet rooftops, etc. Those are things that you need to consider. Does adding a BACnet option to this add a time delay that is high enough to delay the project that I can justify the cost of manually wiring things. Sure, you get a lot more data from a BACnet flow sensor. Sure, you get a lot more data and control from a BACnet rooftop, but you can still largely implement your control sequence with a manual controller and I/O onto that rooftop. It's going to cost a little bit more, but that is an add alternate that you can make. And so you could go down that path. And that is a solution for dealing with this problem, right? That's another solution. An additional thing I want to talk about before I get to Steamfitter's question about floating control and proportional control is the cost of fuel and the cost of shipping product. So I have almost, as long as I can remember, been an advocate of factory packaged controls, both factory packaged, like the embedded controls, as well as factory packaged, shipping your controllers to like Titus or whoever does your boxes, and then having them mount them on the box in the factory and shipping them out labeled. I'm a big fan of that. However, what I have been finding, talking to a lot of our customers, is that the cost of them often receiving the material and then shipping it to the manufacturer is a cost that is becoming quite expensive because of fuel. Now, naturally, your brain, and my brain went to this too. I was like, so why don't you just ship it to Titus or whoever, right? Why does it have to come to you first? Well, in a lot of cases, the actual contracts, and I'm not an expert on this, I'm just going based on what I've heard, so I could be wrong. But a lot of the contracts, as I understand them, require the contractor to receive the product first because they are the approved person who can buy that product from the distributor. And then they are able to go and transfer it to a manufacturer. And you may say to yourself, but I ship product to job sites all the time. Yeah, you do ship products to job sites all the time, but there's still technically a contractor on that job site who's approved to work with that OEM's product, and thus they're receiving the product. So it's no different than if they receive it at the job site versus if they receive it at their actual site. So I'm seeing that going and shipping product to manufacturers, it does have, or to like equipment manufacturers, does have additional costs. But I found out one thing from talking with one of our customers, and hopefully he's not upset for me sharing this, but there are some equipment manufacturers that have specific products that, you know, a good example of this, and I'm not suggesting you use this, but a good example would be Phoenix, right? Phoenix Venturi valves. They typically have their own controllers built into their VAV boxes. Now, I'm not suggesting you start using lab grade Venturi valves for office space VAVs. That's not what I'm suggesting. But he has told me that some manufacturers, some equipment manufacturers, who I'm not going to name here, have their own controllers, or they have stock of controllers. So if you're having trouble getting controllers, suggestion may be to call that equipment manufacturer and ask if they have stock and they could utilize their stock as factory mounted to go and provide product to you much quicker than your potential distributor could get that product to you. You know, like I said, it's just something that's been said to me. I haven't validated it, so don't shoot the messenger. But anyways, so Steamfitter asked a question about, have you noticed any real difference in the longevity of the actuators proportional versus floating? I've personally, I've seen floating actuators fail quickly depending on PID loops and programming. Yeah, so here's how that works in theory. Like if I go to Belimo and I do a Belimo floating point actuator here, and I'm just going to open up this LF24US. This should be a floating point actuator, right? And then if I go to the Belimo, I believe it's LB24SR, that should be a proportional, right? If I remember correctly, because it has a DC motor that, yeah. So what I'm trying to find on here, and I may not be able to find it, but they usually at least if I remember, they had a thing on here that would say how many times this motor could be stroked. And I don't see it on here, but there used to be one. And if I recall, the fact that we're using AC motors versus DC motors, because we're using a DC motor with our modulating devices, and we're using an AC motor with our non. And in addition to that, the aspect that floating tends to have to self-calibrate, it tends to do some other things. You tend to wear those motors out a little bit quicker than the DC motors. There used to be something, and it would tell me how many motor stroke cycles you could get out of the AC versus DC motor. That being said, I can't find it right now. However, that tends to be why you see floating actuators fail, is due to the AC motor aspect of it. Also due to how a floating block works. There's recalibration that usually will happen on a daily basis. It'll recalibrate itself. And in addition to that, there tends to be a lot of back and forth where the clockwise and counterclockwise will tend to fight each other sometimes, versus with the proportional in that DC motor, you're basically just driving it right to the point, and it tends to last a little bit longer, but it's also more expensive. So you're paying for that longevity. I hope that helps. All right, back to our conversation here though. I really, really, really want to point out that product strategies are something you really need to focus on right now, because there are product shortages. They're going to get worse. I know they are building some semiconductor fab plants. I know they're supposedly building like 3 of them here in Phoenix. And that's going to help. But at the same time, you need to be aware that there's material shortages and product shortages, and implementing some of these strategies should help. What I would like to see from the greater community, and where I think we could all come together, is if you have any strategies or tips that you're using to source material, definitely share it. Let folks know, because as an industry, we thrive on being able to execute our work and get building automation systems in place so that people can see the benefit of building automation systems. There's talk of rolling blackouts in Texas and the Midwest. It's insane. There's talks of record temperatures. And what do those things, rolling blackouts and record temperatures, have to do with us? Well, building automation is going to enable our customers to save energy and really ensure that they're controlling their climate within their building. So we need to be able to work together to help folks be able to run their buildings, because the more effectively people can run their buildings, the more building automation systems are going to be put in place. Because something I'm going to start doing personally over the next couple of weeks is I'm going to dive into a series, most likely on Wednesdays, on energy savings and energy saving strategies, and really like diving into that, because I feel that's a value add that you'll be able to sell to your customers, or your sales team will be able to sell to your customers. And I really want us to be able to effectively communicate things like measurement and verification, continuous commissioning, retro commissioning, IPMVP, version or model A, B, C, D, well, probably not D, but A, B, and C, definitely. We should be able to communicate those things, and we should be able to explain the value of those things, because while the construction industry is an 18-month market cycle typically, and our product delays are going to even further extend the build cycles of these buildings, I believe we are going to see a contraction of construction. But I also believe we're going to see an inflation of costs. I mean, we're seeing it right now. We're going to see an inflation of utility costs. And with those things, I mean, I was just reading today, about the new Ford electric vehicle and how, it needs 800 volts to charge it in like a couple hours. And, imagine that. Imagine a bunch of these EVs sitting on the grid. What is that going to do? Our grid is not prepared for that. So where are the folks going to turn to go and try to pull efficiency out of the grid? They're going to look at buildings and they're going to look at residential. You can only put so many LEDs in a house. You can only put so many, high SEER units in a house. You can only put so many PVs on a house and backfeed into the grid. Where folks are really going to start to focus in on is commercial buildings, schools, hospitals, etc. They're going to start to look at these buildings and how can we make them more energy efficient. And unlike a lot of kind of the just crazy green hoopla, I can actually find myself getting behind energy efficiency for that reason, because the reality is we have an old grid, we have undersized production, and we're going to have increased temperatures just for whatever reason. I'm not a climate scientist. I don't know why it's happening. And we're going to have all of this electric vehicle load being placed on our grid. So, because there's talk of giving incentives for EVs and stuff like that, even more than what's already given. What does that do? That increases the cost of our building or of our energy, which is going to really shock a lot of owners. At the same time that all of this is going on, you are having wages go up like crazy, right? You got Verizon, I think they're paying like $18 minimum wage to anyone. It's insane. So naturally, controls contractors are going to find themselves having to increase their wages because cost of living is going up. And, they're going to have to increase their wages, which is going to increase the operational cost to owners because owners aren't budgeting for this. So now they're going to hit double whammy, right? Higher utility costs and also a higher service and labor cost and a higher material cost. So one way we can really help our owner customers is by going and thinking of some strategies that we can help reduce costs. Those are going to be energy, there's going to be analytics, and that's going to be operational efficiency. So you're going to see us starting to really heavily focus on those three topics over the next couple months. All right. Sorry about the tirade there for a bit, but it's something that was just very top of mind, very timely. I don't see people talking about on LinkedIn. I don't see people talking about it really on Facebook. So I wanted to bring it to your attention, get you ahead of the curve, and I hope that it's beneficial to you. As always, everything's available at podcast.smartbuildingsacademy.com/338. Once again, that's podcast.smartbuildingsacademy.com/338. If you could do me a solid, like and subscribe to this episode on YouTube if you're watching it there. If you're on iTunes, please go leave us a 5-star review and a comment. That definitely helps the algorithms, helps us get more exposure. And, it really just helps bring all this information to folks. Thanks so much, everybody, for being here. I will be seeing you all on Friday. I believe on Friday. Let me take a look at what we're going to be talking about here. I believe it's a very interesting topic, if I remember correctly. Let's take a look here at the calendar. It is going to be identifying the true sales opportunity. Now, some of you technicians, some of you are project managers, some of you are operators. Why would you want to identify the true sales opportunity? Why would that matter to you? Well, here's the deal. And here's what I want you to think of. You're going let's just talk selfishly here. You're going for a raise, right? You want to get a raise from your customer or from your owner, from your manager, whatever. The true reason why they need you, maybe they need programming, maybe they've got a ton of projects coming up. Understanding that true reason why they need you, understanding what objections they're going to have, that's going to help you just in negotiating your own salary. But from a customer perspective, I have a very strong feeling that we are going to be shifting to focus heavily on the service market, especially in the institutional market, because whenever markets tend to contract, which we're seeing that right now, whenever that happens, we tend to see money go to municipalities. We tend to see money go to schools. We tend to see money being invested in public infrastructure. And when that happens, that means we need to be able to go and convince owners of buildings to utilize us, which means we need to really understand what their true need is. I will tell you, having been through 2008, the only reason my service team didn't lose anybody was because we were able to go to customers, we were able to identify the energy opportunities, we were able to tie that to local utility funding, and we were able to do retrofit work. And that carried us through while construction jobs were shutting down and projects were losing capital funding left and right. We were able to tie ourselves to that retrofit and energy efficiency funding, and that carried us through. So I want you to consider that, because at the end of the day, one of the things I want every technician, every engineer, every project manager to really accept is that you are your own business. At the end of the day, you can't just depend on your sales team to go out there and sell. You have to find your own work, whether that's through conversations on the job site to find pull through and upsell opportunities, whether that's on a service call and you notice like, man, maybe if we just move that thermostat or if we just adjust that diffuser, these are opportunities that you need to be able to communicate and upsell to people. And we'll be talking about that on Friday. Thanks so much for being here. I appreciate all of you so much that you're here every Monday, Wednesday, Friday with us. And I look forward to continuing to bring you some really cool resources and really cool information over the next coming weeks. Thanks so much, and I will see y'all on Friday. Take care, everybody.